My name is Richard Mina, and I'm joined by Logan Euler, and we are here today to talk to you about GC Image Chemometrics. GC Image is a local company in the Haymarket that builds software to visualize, process, and analyze images from gas chromatography. Gas chromatography is a method of chromatography used in analytical chemistry for analyzing substances to determine what compounds are present in them. Our project, Investigator ML, uses machine learning to further analyze this data. So Investigator ML would take as input a group of chromatograms, and you would be able to classify these samples based on their features. It also allows you to see the differences and similarities between these different groupings. So our main stakeholders and sponsor team were Dr. Steven Reichenbach and Daniel Geschwinder. We met with Dr. Reichenbach on a weekly basis so we could receive feedback on our progress as well as detail some of the improvements we're making. Daniel served as a secondary point of contact if we were unable to reach Dr. Reichenbach, and he is also the person that will be taking control of the repository once we are done working with that. Our team consisted of our squad lead and product manager, Logan Euler, our development manager, Spencer Stream, and 4 developers, Zane Dush, Zoe Fu, Chikang Lee, and myself. Our team was supported by our tribe lead and project manager. Our tribe lead, Dr. Bone, project manager, Melanie Cooper-Wright. They worked to make sure that we stayed on track with our work and that we're following the correct practices. And they were also always there in case we needed any help with anything and just to be supportive.
So GC Image came to us with a working code base, and they were asking us to make various improvements to the algorithms and adding new classification methods, and they wanted more testing for the code base as well as just various improvements for the program overall. So our solution did provide more algorithms and classification techniques that can be used now, and we also made different data visualizations for multi-class data sets. At the beginning of the project, the codebase only worked on binary data sets, so when we moved to multi-class data sets, it was a big shift in the algorithms and the data visualizations that we could use. We also worked on unit and system testing frameworks, and we worked on building a scalable architecture. We had to go in and refactor a lot so that when we added new features, it wouldn't be a big hassle to do so. And if they wanted to add more features in the future, they would be able to do that as well. So here's some screenshots from the solution that we built. One of the things you can do is analyze the features and look at how each class has a different distribution of features from the others. So on the left here you can see a screenshot from that window in the program with 6 class distributions for an acetic acid feature. And then on the right here you can see our configuration tab. We found it really important for the user to be able to control a lot of the different things going on in the program. So one of the things we included were different settings that they could control. So here you can see different cross-validation techniques that they could use with different parameters. Cross-validation is just a process where you take samples out and then you build a model with the remaining samples, and then you test those samples on that new model to see how well the model might be able to be extrapolated to different samples outside in the real world. So here's some more screenshots. On the left here, after you run a classification method, we show a bunch of statistics for the performance of the model and each of the classes within there. You can see some confusion matrices for this 2-class data set and see how different sets performed, like the testing set, the validation set, and our training set. And then we also have different graphs that you can view inside of the classification results, like scores graphs. Here you can see a scores graph from linear regression on a 3-class data set, and so you can visualize better which samples performed well and which ones might have been misclassified or performed worse than others in that particular model. So now I'm going to go ahead and open up the program and run a demo for you. So the first thing we're going to do is open up a CSV file with the data set that we want to use. Here on the opening screen you can see a lot of pre-processing analysis that we do with the data. You can see different graphs based on how well the sample is placed within a certain class, and you can do this on a pairwise with each of the classes. And then you can also view some feature statistics like ANOVA scores and different things. You can also choose which samples and features you want to use or not use within a classification technique. We also have a feature here where you can click a button and it separates a portion of the data into testing versus training, randomized, so that you have a better idea of how it might test in the real world. If we run a KNN classification here, you can see some performance statistics and different things for this. You can also see some scores graphs. For KNN, the scores represent how many neighbors were calculated in each class for that sample. So the true class scores are positive and the negative class scores, and the false class scores are negative, so you can better visualize which samples performed. Another feature that we have is if you change the normalization techniques, you can go ahead and see how the feature distributions change. And then if we run another KNN classification here, you can see that the different performance metrics changed along with it, and see which classes and which samples benefited from that. So now that we're done with the demo, we can talk about some of the value and the highlights of the project. So obviously GC Image is going to get a large jumpstart on finishing the product and releasing it to the public, but we also got a lot of experience as well. We had an opportunity for first-hand experience with machine learning and maintaining a working repository. So I didn't know anything about maintaining task boards and different backlogs before this, but I know a lot about them. And we also got a better familiarity with Java and JavaFX, which is how we built the GUI. And we also used JUnit for the unit testing and the rest of the testing framework, so that was also very helpful to know at the end as well. We just want to say thank you one more time to GC Image for giving us the opportunity to work on this project. It was a great experience working with you, and thank you for listening to our talk.